So let's have a look at the operation of functions. So we're going to find the sum of a function, the difference of a function, the product of a function, and the quotient. And we're given two functions. So let's have a look at the sum first. So the sum can be written as f of x plus g of x. So this is just going to be x minus 4 plus 9 minus x squared. Now we cannot simplify this any further, so that is our answer. But now we need to find the domain. So I'm just going to go over here. So the domain, so if we look at f of x, this is x minus 4, and this is a polynomial. So our domain is going to be all real numbers from negative infinity to positive infinity. Now if I look at g of x, this is a root. So we have some restrictions where this has to be greater or equal to 0. So I'm going to take the 9 minus x squared and make this equal to 0, and I'm going to solve. So add in x squared to both sides, so x squared is equal to 9. And if I take the root of both sides, this is going to be plus or equal to 3. So we're going to have positive and negative. So the domain here is going to be included because it's equal. So from negative 3, and it's going to be to positive 3. So this is our domain. Now, first to find the domain, when we add the functions f of x and g and plus g of x, this is going to be what is common, the intersection of both. So in this case, our intersection is going to be the domain of negative 3 to 3. So let's have a look at the difference. So this time we've got f minus g of x, and we can rewrite this. So this is going to be f of x minus g of x. So for our functions, we have x minus 4 minus, now I'm going to put this in brackets, and we have the root of 9 minus x squared. And now I'm going to simplify. So we have x minus 4 minus 9 minus x squared. So that's just going to be the same. So I'm going to look at the domain. So to find the domain, so if we take the domain, we know that the domain for, we said, for x minus 4 was all real numbers. And then the domain for 9 minus x squared, the root was going to be negative 3 to 3. So the domain is going to be the same, negative 3 to 3. So the product, this is going to be f multiplied by g of x. So we're going to rewrite this so as f of x multiplied by g of x. And our functions we're using, so we've got x minus 4, and this is multiplied by, so I'm going to put these in brackets. So this is x minus 4, and then we have root 9 minus x squared. So we're going to distribute each of these. So if I multiply everything, so I'll have x 9 minus x squared. So I'm multiplying this together, and then I'm going to multiply this. So then I will have minus 4 9 minus x squared. So the domain, this is going to be the same as in the previous question, because we're looking at what's common to both. So this is going to be negative 3 to 3. So now we'll have a look at the quotient. So this is f divided by g of x. So now we have our function. So this is going to be slightly different. So looking at this question, we have x minus 4. So we're going to write this as f of x divided by g of x. And this is going to be x minus 4 divided by the root 9 minus x squared. Now this time it cannot be equal, the denominator cannot be equal to 0. It'll be undefined, only greater than 0. So if we were to solve 9 minus x squared is greater than 0. So what we're going to do is factor this. So it's difference, so we'll have 3 minus x and we'll have 3 plus x is greater than 0. So let's take them both. So I'll have 3 minus x is greater than 0, or 3 plus x is greater than 0. So this is going to be x is less than 3, or we're going to have here, I'm going to take that, x is greater than minus 3. So if I'm to look at this on the number line, this is negative infinity, I'm going to have negative 3, and I'm going to have 3. And then it says x is less than 3, but x is greater than minus 3. So we're looking at this area here. So our domain is going to be, it's right here over here. Our domain is going to be negative 3 to 3 with the round brackets this time. Okay, so have a look at this question. So finding the sum, the difference, the product. Let's make sure that's filled in. Product and the quotient. So let's have a look at the sum. So we want f of x plus g of x. So let's have a look. So we have x squared minus 6x minus 8 plus root of x. And we're looking to see if we can simplify this in any way. No, we can't. So let's have a look at the domain. So the domain for f of x, this is a polynomial, so this is just from negative infinity to positive infinity. And g of x, this is a root, so this has got to be greater than 0 or equal to 0. So this is going to be from 0 to infinity. So if we look at what is common to both, the domain is going to be 0 to infinity. Oop, round bracket. Round bracket. There we go. So round bracket for that one. Let's have a look at the difference. So let's see the difference for this one. So if we look at the difference, this is going to be f of x minus g of x. And this time we've got x squared minus 6x minus 8 minus root x. This doesn't simplify. The domain is going to be the same. So the domain is going to be 0 to infinity. Let's have a look at the product. So the product, we have f of x multiplied by g of x. So this time x squared minus 6x minus 8. And this is multiplied by root x. So we need to multiply all our terms. So this is going to give us, so we'll have, if we multiply this with this, first we're going to have x squared root x. And then I'm going to multiply our middle terms together. So then I will have minus 6x root x. And then I'm going to multiply our last terms together. So this will be minus 8 root x. Now, can't simplify that any further. The domain is going to be the same. So this is going to be from 0 to infinity. So looking at the quotient, so this time it's going to be f of x divided by g of x. And we have f of x is x squared minus 6x minus 8. And this is divided by root of x. So this time it cannot equal 0 on the denominator because it will be undefined. So it's got to be greater than. So this cannot be equal to 0. X must be greater than 0. So this time our domain is going to not include 0, but it's going to be all the values to infinity.